In Lesson 4-1, we're going to learn how to use graphs to relate two quantities. The graph you see relates time to distance traveled. And this might be a graph of someone who is traveling from home to school. The distance at 0 would be the moment at which they are home. And when the distance is up here, whatever that is, that might be when they're at school. So this graph shows that they started at home and traveled for some time at a certain speed, and then they stopped. That is, the distance remained the same, so they had stopped, and perhaps that was for a stop sign or a stoplight. And then they traveled at a much faster pace, and then traveled some more at a slower pace, and then they stopped, and presumably this is when they were at their destination. I'd like to show one more example of analyzing a graph. This illustrates why we need to look at the units on the graph very carefully. So on this graph, we notice that the graph is a time versus speed, not time versus distance. Now what this graph is telling us is that when we started our journey, we were traveling at a certain speed, and then we slowed down and stopped for a period of time, and this indicates here that our speed is 0. Then our speed got faster, so we accelerated up to a high speed, perhaps to be on a highway, and then once we get off the highway we slow down to a much slower speed, and then we slow down to a stop, at which point we've reached our destination. This doesn't really tell us how far we traveled, it just tells us how fast. Problem number 2 in this chapter is about matching a table and a graph. I'd like to show you two different tables and their respective graphs to help you understand how to do the matching. So here's graph number 1. This graph relates the number of books to the weight of, let's say, a briefcase or a backpack. The table shows X as the number of books and Y as the total weight of the backpack and books. Now you'll notice that with each book, the weight goes up by 6 pounds. And when you make a graph of a function like this, the points will line up in a straight line because the differences are all about the same. You'll also notice that we only plotted points. We did not connect these points with a line. And that's because it doesn't really make sense to think about how much a backpack weighs with 1.5 books or 2 1/4 books, because we can only put the books in one at a time. Now let's look at this graph. Here we are going to graph the number of days that our advertisement has been posted on the internet, let's say, and see the number of customers that come into our store during that entire day. The first day after we posted the ad, there were only 3 customers. The next day there were 6. The next day there were 12. And then the next day there were 24, and then 48, and then 96. And you can see that when the number of customers increases in this manner, the increases get bigger, that the graph will tend to look like it's curved. Once again, we're going to graph with dots and not connect them because we're only taking measurements once per day and we're counting the number of customers during that entire day. We're not counting half days. Here's a problem for you to do. You fill a glass with water and leave it out on a table, and each day you measure the water level. The table shows the water level each day. Which graph best represents this situation? Stop the video, make your decision, and then restart the video to find out the answer. Graph C is the one that best shows this situation. If you look at the water level goes down by 1/2 inch each day, so it goes down at a steady rate. This first graph, you can see that the water level does not go down at a steady rate. It starts going down faster and faster as time goes on. The second one shows the water level going up. So the third graph is really the one that shows this table most accurately. In problem 3, we're asked to sketch a graph based on a situation, and we're also asked to label the graph. So here's how you do that. The situation is that on Monday there was a huge snowstorm. The next 2 days were cold, so the snow didn't melt at all. Then the temperature warmed up a bit and some snow started to melt. 3 days later it got really warm, and within 1 week most of the snow melted. Sketch a graph that could represent the depth of snow in your yard. So here we'll start with no snow and a huge snowstorm, and that put all of the snow on your yard. Then we had a couple of cold days, so there was really no change in the depth of the snow. It got a little bit warmer and it melted a little bit, and then it got really warm, so it melted very quickly, and at the end of 1 week we see that most of the snow has melted. So take a moment to notice how I labeled the axes of the graph, how I drew the graph and labeled each section of the graph according to the problem, and that the graph has no numbers associated with it. It's just an approximate graph. Here's one for you to try. I'd like you to draw graphs that model this situation. Today's workout is a combination of walking and running. You walk for a few minutes to warm up, then run for a while, then do a quick sprint. You take a short rest and then walk home. I'd like you to make a graph of the distance that you've traveled versus time. This is not distance from home, but it's distance that you've traveled versus time. And then as a challenge, I'd like you to make a second graph of speed versus time. Summarize this in your journal. Make the two graphs. Stop the video while you're doing that, and then restart the video when you're ready to check your answer. Here's what the distance-time graph looks like. This first section here is where you were walking. The second section here is where you were running. And you can tell that the running part is faster because the slope is higher. So this is the walk. This is the run. Here you're sprinting. Here's where you stop. And then here's where you walk home. Now, if you did the challenge, here is what the speed graph looks like. Now here is where you walk, and then your speed goes up when you run. Speed goes up even more when you sprint. And then this is the rest, and this is the walk home.